For question 1a, what we actually need to do is actually to get the f prime x graph from the graph given to us. So, as I mentioned it before, to actually get the graph of f prime x, what we actually need to do is to actually determine the turning point first. From the graph of y equals to fx, it's very clear that the turning point is actually at minus 1, 0 and minus 3, minus 4. Hence, for the graph of y equals to f prime x, we have to put in the points minus 1 and minus 3, since we know that at these 2 points, the value of f prime x is actually 0. Next, we actually look at the vertical asymptote. Originally, for the y equals to fx graph, we have the asymptote being x equals to minus 2. This will also means that it is also the vertical asymptote for the y equals to f prime x graph. Reason being that at this point, we cannot find any value of gradient. But for this question, the only slight unique characteristic about it is that it actually has an oblique asymptote. Now, if you look at the graph of y equals to fx, well, we can actually see that when x approaches infinity, the value of the gradient of the graph actually approaches to the gradient of the oblique asymptote, which in this case is actually 1. Hence, for this f prime x graph, we actually have to put in the horizontal asymptote y equals to 1, because we know that the value of the gradient approaches 1 when x approaches infinity. And we are ready to sketch. Now, if you look at the questions carefully, from value that is actually bigger than x, for the value of x that's bigger than minus 1, we can see that the gradient is actually positive. And for the gradient of the graph between minus 2 and minus 1 is actually negative. So we have to show the graph like this. And using the same concept, we can actually complete the graph for the other side. Okay, for question 1b, what we actually need to do is actually to find the equation of the tangent to the curve at x equals to a over 2. Now, the equation of the curve that's given to us is in terms of parametric form. However, the step of finding the equation of tangent is the same. The very first thing we need to do is actually to find dy dx and then find the value of the gradient using the expression of dy dx at x equals to a over 2. So, to start it off, we need to get dy dx, and since it's actually the equation of the curve is given to us in parametric form, we will use dy dt over dx dt to find out what dy dx is. So a simple simplification, should I say a simple differentiation, we will actually have minus cotangent t to be the expression of dy dx. Now next is a step that student actually will forgot a lot of times, is that we cannot actually put this whole expression of dy dx into the tangent. We must actually substitute so-called x equals to a over 2 into the expression of dy dx. Now, the expression of dy dx in this case has the expression in terms of t. Hence, we need to find the t that corresponds to x equals to a over 2 using the parametric equation. So, let the x to be a over 2 in the parametric equation, and we will find out what the value of t should be. Cosine t equals to half. This will imply that t equals to pi over 3. So after I get t equals to pi over 3, I will put it inside dy dx. And the calculations will give me minus 1 over square root 3. Now, after I get the value of dy dx, we can actually start to find the equation of the tangent. Now, the equation of tangent, what I usually use will be y minus y1 over x minus x1 equals to m, where m is the value of the gradient. Now, some of the students may use y equals to mx plus c. However, the choice actually is up to them. So we have y minus y1. Now, the thing is, what is y1? y1 is actually the y coordinates for the point where the x coordinate is a over 2. Now, the coordinates have one thing in common, which is the value of t. So you just sub in the value of t that you found just now, pi over 3, into the parametric equation for y, you will be able to get the y1. So this is what you need to do. And the value is actually minus 1 over square root 3. So after reaching these steps, the remaining step is basically simplification. So x. So what you actually have will be y equals to square root 3a over 2 equals to minus 1 over square root 3 multiplied by the whole of the denominator. So a simple simplification. Okay, at this step, you do have to take note is that if you look at the equation that's given to you, you actually see that the y is actually accompanied by the factor 3. Now, this actually means that we may need to multiply 3 throughout the whole equation to actually find out what you need. So, what I actually will do here is actually multiply 3 throughout the whole of the equation and hope that we will be able to find the expression that we need to show. So here we were left with minus square root 3x. Here we will actually have square root 3a over 2. Here we will actually have 3 over 2 square root 3a. So this thing here is square root 3 over 2. We can actually, what you can actually do is you can actually factor out square root 3a. And you will see that yes, we actually get the thing that we need. Okay, for part B, part 2, what we actually need to do is to actually find out what is the exact area of the triangle OQR. Now, it will be good that you have a diagram to actually show you what triangle OQR actually is. Now, the Q is actually defined by the point whereby the tangent meets the x-axis. So what we can actually do is to actually draw the tangent out. Okay. Now, how do I know that the tangent is actually having a negative gradient? Well, just now what we actually see is that the gradient is actually minus 1 over square root 3. So this is why I would draw my tangent like this. Now, with this, I think we will be able to put in where is O, where is Q, and where is R. Now, if you look at this picture carefully, in order to find this area, what we actually need to do is just to actually find out what this marking is and this marking is. Then we will just use the very basic formula for the area of the triangle: half times base times height. Okay, so how do I actually get the marking? Well, that marking is actually just the x and y intercept of the equation of the tangent. So what we actually need to do is, when x equals to 0, this is to actually find out what the marking for Q is. We will use the equation that we found just now to see that 3y equals to square root 3 2a, and hence y will be equals to square root 3 over 3 2a. So this marking here, or should I say the height, is actually square root 3 over 3 2a. Next is to find out what is the base when y equals to 0. Again, using the equation that we have just now, we will have square root 3 2a minus x equals to 0. This simply will just say that x equals to 2a. So the base is actually 2a. So once we know the base and the height, what we actually can do is to just apply the formula. Area equals to half base times height. Okay, and we will just do the simplifications. What we actually will have is 2 over 3 square root 3 a square. Okay, let's have a check of the solution. Yes, and that will be the answer. Okay, for question 1 part C, what we can see is that we will need to use differentiation to find out what is the minimum volume of the material used to create that container. Now, in order to do these questions, we will always have to find an expression for the volume of material being used, and since we need to find the value of the x that will give this minimum, what we need to actually do is to actually form an equations of V, which we will let it to be the volume of the materials in terms of x. So what we can actually do is we actually know that the internal length is actually xcm, so we can actually also find the external length of the whole rectangular block, or the whole of this container. The only problem is that we do not have the so-called the height of the internal volume. So maybe we will let h to be the internal height. Okay, so what I'm actually referring to is, if I actually do a drawing like this, okay, h is what I'm going to define for the internal height. So the thing is, we will be able to find out what is the volume of the material being used by actually find out what is the volume of that whole container minus of 1000, because we know that the internal volume must always stay as 1000. So the expression for V will be x plus 2. This is the external length multiplied by x plus 2, since the base that we have is actually a square base, multiplied by h plus 1 minus of 1000. Okay, however, we are not able to do any differentiation yet, because the problem is that we must always make V to be only in terms of x. So we need to actually find out what is h in terms of x. From what we can see is, okay, the internal volume must always stay as 1000, and by the definition of what we have for h, we can actually see that x squared times h is actually the volume of the internal volume, which is actually 1000. So h is actually equals to 1000 over x squared. So from here, we will be able to express V in terms of only x. Okay. And from here, what we can actually do is to actually make it out term by term, and try to create a more simplified equation for V. Okay, so the simplified equations will be x squared plus 4x plus 4 plus 4000x plus 4000x squared. So what we do is we will have to find dv dx. Okay, and in order to find the minimum value of the x, what we can actually do is to actually let dv dx to be equals to 0, And what we have is so doing a bit of simplifications, what we will have is actually 2x to the power 4 plus 4x cubed minus 4000 x minus 8000 equals to 0. Okay, you are facing a polynomial of degree 4. Now, if you read the questions carefully, we actually no need the value of x to be exact. So what we can actually do here is to actually use the GC to help us to solve the question. So most of you will actually do that, use the applications, poly simultaneous solve, or okay, let me find the application first. Okay, poly simultaneous, enter. Now the GC that I'm using now is of an older version, so it may looks a bit strange. However, the function is still the same. So x3 is 4, a2 is 0, a1 is minus 4000, and a0 is minus 8000. So if we do the solving, you can see that we actually have one real value, which is 12.6. So are we done? No, because for these type of questions, whenever you're dealing with maximum minimum, you will have to show that the value of the x that you got is actually the x value that will give you the minimum. Now the checking can be done in both ways. One, you can actually go and find out what d square v over d square x dx square is, and just to show that when you sum in this x value, it will give you a positive value. However, since we already know that there's only one value that satisfies, what we can actually do is just to create the table itself. And then, depending on whether you want to do it or not, here you can actually just say that, well, this will be give you a positive value, negative value, and hence at x equals to 12.6 cm, the volume material being used is minimum.